So yeah, again, my background is in geography. I'm not an entomologist, and so I'm trying to catch up as quickly as I can. I've been in grad school a couple of years now, and done as much reading as I can, but I still find some of the entomological details to be a little over my head at this point. My primary interest is in, well, I should explain that initially I started researching the San Juans to reconstruct past outbreak histories. Our biogeography lab had some research scholars to go into the forest and collect some dendroecological data that might give us insight into past patterns of outbreaks. While hiking around the San Juans and seeing what was going on, and more or less seeing the astonishing changes that are going on in certain parts of the San Juan, I became really interested in why the outbreak had become so severe in some areas and had become not so severe in others. And I started playing around with the aerial detection survey data and came up with some ideas and testable hypotheses about why the eastern Weminuche has been just hammered by spruce beetle. The western San Juans have seen very little activity, and the southern San Juans have seen sort of a middle ground where activity has continued on at kind of a moderate pace. A few things. This talk, I'm not going to go into a ton of details. I don't have a ton of analysis and conclusions to present today, but I do hope to present some spatial patterns that we've observed via aerial detection survey data and also from being on the ground, sampling plots on the ground. I also hope to present some snapshots, some photos, and some data that will give you all an idea of what the picture is on the landscape, on the ground, in valleys throughout the San Juan Mountains. And then also present a few ideas that we have for explaining some of these spatial patterns. One thing we can say for certain is that this outbreak is very high severity in some areas. This is from Indian Creek Valley. This is near the Williams Creek Reservoir. Many would say this is sort of the epicenter where the spruce beetle outbreak started. Not the outbreak, I should say that the outbreak in the San Juans is many outbreaks. That's kind of the way I view it. But this was sort of the granddaddy of them all. This is the one that has sort of produced the largest extent and highest severity damage. The two live trees in this picture are fir. You'll notice that there aren't any other live trees in the picture. That's because of one, spruce mortality is almost complete here, and also because species diversity is very poor in the San Juans. It's almost entirely spruce. And my sampling strategy is I picked 19 valleys at random across the San Juans. I established 40 high elevation plots in each of those valleys and sampled for species status, so live, dead, infested, and basal area. So I have a pretty good snapshot for each of these valleys, and many of my plots were pure spruce. In fact, one valley was entirely spruce. I did not see a single subalpine fir, adult or small trees. And I had another valley where there was one pocket out of 40 stands, 40 plots, there was one pocket of subalpine fir. The rest is pure spruce. So there is a lot of Engelmann spruce out on the landscape here in the San Juans. Another thing we can say is that this outbreak is unusually severe, at least in the context of the last several hundred years. So this is up in the headwaters of Williams Creek, near to the Indian Creek area. All of these trees are dead. Many of these large Engelmann spruce date back into the 1500s. So if a high severity outbreak like this had occurred in the last couple hundred years, we wouldn't have trees of this age, this many trees of this age out on the landscape. And there is a lot of old spruce in the San Juans. We can also say that this outbreak is affecting the very highest elevation spruce forest out there. So this is tree line location, middle fork of the Trout Creek. This drains actually towards the Rio Grande. The Continental Divide Trail runs right along this ridge, actually around the buttress, right about there. So this is a tree line location. And the outbreak is still active. We saw last summer, I was out in the field from May through August, and we saw lots of beetles flying a flight in the Lagaritas. We saw beetles flying around June 10th through June 15th. Beetles were flying north and east. So this outbreak is still very active, probably not news to many of you. Some motivations for my research. Where did the outbreaks initiate? That's kind of an interesting thing to look at, since initiation is a very important part of beetle outbreaks. Which outbreaks became severe? Are all outbreaks created the same? Or did some outbreaks take on different trajectories? Why didn't outbreaks occur everywhere? If this outbreak was triggered by drought, or was sort of set up by wind throw and then exacerbated by drought, drought tends to be a regional process. Why don't we see outbreaks in all stands across the San Juans? And how have outbreaks occurred in the past? So these are some things I hope to get at today. Just some background. Detection of this outbreak originally popped up in 2004, as Barbara mentioned. Overflights of the San Juans were very scarce in the early 2000s. In 2004, a very small proportion of the San Juans were surveyed. From 2005 on, most of the San Juans were flown, with a few exceptions here and there. Tree ring data suggests actually that there might have been some elevated beetle activity even into the late 1990s. I won't go into the details there. It's still kind of just a hunch that we have based on tree ring data, but certainly things were ramping up in the early 2000s. And some of that lag behind the mountain pine beetle may actually be due to just the lack of detectability. Dying spruce are harder to detect than dying mountain pine beetle. Spruce don't turn bright red, bright orange when they're getting attacked. It takes a couple of years sometimes. There was a major avalanche cycle in January 2005. Obviously, major avalanche cycles that cut new pathways or that trim and expand existing pathways can provide a nice pool of weakened or dead dying spruce borer beetles to attack and build their populations in. But the timing of this, it may have served to exacerbate the outbreak, but the timing doesn't indicate that it would have triggered it directly. And this outbreak has currently affected over 800 square kilometers. So the data sets that we deal with, I've got a ton of plot surveys from hiking all over the San Juans last year. We used the aerial detection survey data just for sort of a coarse feel for spatial distributions. We don't take the boundaries of those polygons too seriously, but they are good for looking at landscape scale patterns. We use tree rings for various things. We can tell a lot by looking at the growth of a tree. And we've been using some interpolated weather and climate data to look at drivers such as temperature and drought. So just when I talk about the San Juans are kind of a big area, and I've broken it into a few chunks. This is showing the geography, sort of the elevation of the San Juan. The dashed line is the Continental Divide. Forms kind of a horseshoe shape, so this is the Rio Grande range out here, San Juan flowing this way, and Uncompahgre to the north. The way I just talk about the San Juans is I break it down like this: western and eastern halves, more or less, and then that eastern chunk I call this sort of the South San Juan wilderness, more or less from Wolf Creek Pass on down. I refer to that as the southern San Juans, and then the Lagaritas I just call the northern San Juans for consistency. Sampling, so I picked 19 valleys at random. They fell across the San Juans like this. You can see I actually stratified so that I had a proportionate number of valleys in each geographic quadrant of the San Juans. Some of these valleys had been logged in the past. Some had not. Just to give you an idea of what the plot level. So this is Wolf Creek Pass. This is the road going over Wolf Creek Pass. The ski resort would be here. And you can see I put a grid of plots. So the valleys were selected at random. The plots themselves saturate the headwaters of those valleys, and they're at approximately 350 meters from one another. So a grid across the headwaters region. These polygons are showing the 2004-2005 overflight. So that's where these are Spruce Beetle polygons as of 2004-2005. So that's sort of the initiation period. So where did outbreaks initiate? This is some kind of combining a few years here, like Barbara mentioned. The annual resolution of these aerial detection surveys is dependent on where people fly. But this bright purple shows that the San Juans were hit initially in those first 3 years pretty hard here across the eastern William and Newton area. But notice there are patches throughout the southern San Juans. Here down by Cumbres Pass, here up in the northern San Juan, in the Lagaritas, Benito Creek got hit pretty hard. Notably, this valley was logged back in the 60s or so. And then we have fairly extensive amount of outbreak in the West Cimarron Valley. 2006, some polygons showed up here in the west. So kind of a regional scale outbreak, definitely not, but definitely heterogeneous, right? We've got a lot more activity in certain parts of the San Juans. So this is adding the next 3 years, 2007 to 2009. A lot of things filling in this part of the San Juan. No additional activity in West Cimarron. That outbreak seems to have just shut off. Some kind of slow, progressive expansion of outbreak in the southern San Juan. Nothing in the north, very little in the west. And these are the last 3 years. Considerable expansion in the last 3 years, sort of radiating from this central point here. This pattern does indicate, at least spatially, that the beetles in this part of the San Juan, in the northern San Juan, is part of this outbreak that has radiated from the eastern William and Newton wilderness. Some other things to point out. Expansion in the southern San Juan, but at a very slow rate. In the western San Juan, just in the last few years, we've seen additional spruce beetle outbreaks popping up. Near western Cimarron, no additional outbreak. And I didn't see any, I was there last summer, I didn't see any signs of any ongoing spruce beetle activity there. So for my plots, I was able to summarize the outbreak severity. So this is basal area. These pie charts are giving us the proportion of spruce that are alive, which is shown in green, infested, shown in yellow, and dead, which is shown in red. You can see that the eastern William and Newton area, 80 to 90 to 100, I should say 90 to 100% of the basal area there is either dead or infested. You can see here, very high proportion has just been hit within the last couple of years. These are infested trees. The southern San Juan, kind of a mixed bag. And western San Juan, still a lot of healthy forest.
So when you're talking live, are you using all size classes?
Yeah, so I used because I wanted to be able to sample really quickly, I used the variable radius plots. I use a prism. And, but for each tree that is in, which counts towards the basal area, I would record the species, the status, and the diameter of breast height. So that technique, by its very nature, kind of undersamples the smaller diameter trees. It's mostly counting the trees that are really important in terms of basal area. And if we break this down a little bit more and we look at the individual plot level, so this is La Plata Canyon. Just use this as a heuristic tool here to show you what these graphs are going to look like. So each dot represents data from a plot, a specific plot in the valley, along elevation, and then these are our severity. This is kind of a continuum of severity. So plots that are being shown down here have very little beetle activity, beetle mortality. If plots were up in here, that would represent 100% of the basal area being killed or infested. So that's this little locator map shows you La Plata Canyon. So obviously a little bit of activity there, but not a lot. Getting a little ahead of myself here. So the western San Juan, we see a lot of these plots showing no mortality or very little activity. This is showing percent of basal area that's dead or infested. West Cimarron, again, you can see kind of that pulse, that early pulse is represented by these plots here. But overall, the health of the forest there is it's still pretty good. Not quite as much beetle activity. In the eastern San Juans, it's the complete opposite. So this is Wolf Creek Pass is right here. 90 to 100% of those trees are dead or infested right now. And there's a lot of young trees that are, especially in Wolf Creek Pass, that are doing really well. And then further west towards the Continental Divide, the headwaters of the Rio Grande, kind of a mixed bag. This is that pattern in that valley is very similar to what we see in the southern San Juan. Northern San Juan, very high mortality. This is Rat Creek in the Lagaritas, north of Creed. And the quality of image is that great, I guess, but pretty much all of these trees are dead. These are pretty small trees here in the foreground, near tree line. Certain parts of the San Juans, particularly in the eastern Weminuche, we've seen trees as small as 5 centimeters DBH that have been killed. The beetles just seem to be sort of desperate in those areas. Southern San Juan, very much a mixed bag. Lomanga, this is a valley that's been logged in the last 50 years. Rio Pinos, that's more of a wilderness. This is Rio Pinos right here, sort of from about here on down. We've seen a fair amount of logging. Verde Creek, that's in the wilderness. Lots of basal area in that creek. Lots of basal area, lots of large trees, and we see hardly any spruce beetle activity. Yeah, so again, there's some strong patterns of outbreak. I'm interested from a research perspective in why these patterns exist. Why did outbreaks pop up all over the San Juans, from north, south, east to west? But only the outbreaks originating in this part of the San Juan erupted across the landscape, causing the vast majority of the damage that we've seen today. And probably the reason that we are here today is because of the outbreaks that started in this part of the San Juans. So these are the outbreaks that took on a high severity trajectory. So why didn't outbreaks occur everywhere? Well, one option is maybe there's just more trees. Well, if we look at these valleys going across the San Juan, these are sort of organized from west to east. So this is La Plata over here, West Cimarron, which is over by Uray, is here. Indian Creek, South Fork Rio Grande, this is Wolf Creek Pass, this bar, and then the southern San Juans, and then these 3 bars over here are from the Lagaritas. I don't see a ton of strong patterns here. Now again, I'm large on data and short on analysis at this point, but these are the valleys that produce the most severe outbreaks. And just to my eye, I don't see a lot more spruce basal area in those valleys compared with others. In fact, it seems as though the southern San Juans tend to have more spruce basal area. And another thing to notice, so green represents spruce basal area, blue would represent subalpine fir, yellow is aspen. A lot of spruce on the landscape. Most of the basal area out there is spruce, really without exception in the San Juans. Maybe there's more big trees. Maybe it's not that there's more trees. Maybe there's more big trees in certain parts of the San Juans. Well, again, if we look at those valleys where the high severity outbreaks occurred, now I've broken those green bars up into different size classes. So spruce that are larger than 25 centimeters DBH, larger than 50, larger than 75. So the largest trees would be represented in this dark green color. Again, I'm not seeing a lot of strong patterns emerging. Again, I plan to use some modeling techniques to try and disentangle some of the nuances of this data set. Biggest trees are out here in the La Platas. The largest spruce I saw all summer was about 1.5 meters diameter breast height in the La Plata drainage. Lots of big trees in the southern San Juan. So again, this doesn't suggest to me that this is an obvious cause. How about drought stress? Well, so we also have another component. Rather than just sampling in the valleys, we're not looking for drought stress spruce across the range that might show a signal for differences in regional drought stress. So this is us, me and my girlfriend, heading out to a field site. This is from Vallecito. We were planning actually on skiing into these sites in the spring, and of course the runoff came so quickly we pushed our sampling back a week, and we could just mountain bike into some of these spots. So we went looking for, dry, exposed, rocky, thinly soiled areas. This is Runlet Peak, so we sampled spruce there. That had a nice climate signal. And we sampled locations like this. These are very drought-stressed spruce. A lot of these spruce in here, they're not exceptionally big, but they're 300 or 400 years old. They have a fairly decent climate signal. I sampled several sites. These 8 turned out to be nice and drought sensitive. You'll notice I didn't manage to get much in the northern parts of the range. So you core a bunch of trees, you process the cores, compile them into chronologies, and then the way I looked at this in terms of an analytical framework is how does the 2002, 2003 drought, how does that compare to previous droughts that tree has recorded? So these dashed lines for each of these chronologies, these dashed lines indicate the most, essentially the smallest ring width that tree has experienced, the strongest amount of drought that tree has experienced. And there's a little bit of difference here. So in the far southern San Juans, we see that the 2002, 2003 drought wasn't the most severe. Robinson Gulch again, here, very old trees in this site. It seems as though, I think it was the 1850s drought showed up as the most severe for that site. Northern San Juan, this Hanson's Mill site, I think the 1850s drought again was the one that this site felt the most strongly. The rest of the sites all seem to be showing that the 2002, 2003 drought is the strongest drought that trees on that site have experienced in the last couple hundred years. So the 2002 drought was pretty hard on the forests across the San Juans. Looking at this from a weather perspective, so this is the PRISM data for 2000 through 2011, and I didn't put any points of reference on here, but you can kind of see that this is the high elevation region of the San Juan being heavily drought affected in 2002, and it is suggestive that this eastern portion of the San Juan, which is where the most severe outbreaks sprang up, did in fact experience a lot of drought, and that the western San Juan maybe experienced a little bit less of a precip deficit during that 2002 period. And then again in 2003, things were closer to normal in the western San Juan. So this is suggestive that perhaps the drought wasn't equal in all parts of the San Juans, and that could help explain some of the trajectories we see on the landscape. How about prior disturbances? So certainly there could be more trees or bigger trees, there could be stronger drought. How about prior disturbances that may have boosted the levels of beetles that were out in the landscape? This is my dog out on a fallen Engelmann spruce. This is in West Cimarron Valley. So this is that valley that sort of popped up early and then the outbreak just seemed to go away. If we look at the underside of that tree, lots of holes from beetles that attack that tree. So this is just kind of an illustration of how beetles persist in the landscape. They take advantage of natural wind-thrown trees on the landscape. So just thinking in terms of the history, so it's complicated. This could be the case. We don't really know how to get to beetle pressure directly. But it's plausible that perhaps some wind throw preceding this drought is sort of what set the stage for the outbreaks we're seeing today. And this is kind of the pattern that I'm most interested in now, is perhaps wind throw in the eastern Weminuche allowed beetle populations to kind of rise up and increase, and that's what put the balance once the drought hit. But again, this is me just sort of brain dumping my ideas on you about the things we're investigating, some of the causes that could result in these spatial patterns of outbreak. We've looked at past outbreaks. We've cored dead trees. I'm going to just kind of fly through this because I'm running out of time. We've cored live trees. The dead trees and the live trees give us information about past outbreak history. If you core a live tree and you look at its growth, oftentimes you see a sharp increase in growth by understory trees once an outbreak kills off the overstory. Those trees are essentially starved for light. And once the overstory is killed, they get a nice big pulse of sunlight and they can start growing a lot more rapidly. And so that's one line of evidence that can hint at an outbreak, at past outbreaks. We sampled in the eastern Weminuche, areas that have been hit the hardest. And this is what we found. So this is data from dead trees, trees that were killed by Engelmann spruce beetle in the past. These are all standing trees, so they were not wind-grown. And in these different valleys, I'll point out a few patterns. We see that there's beetle outbreak in San Juan is common. There's a lot of beetle outbreak activity, a lot of beetle activity in the San Juan. We see outbreaks in the 80s, 70s, 60s. We see kind of a level of pressure here in the 50s, 40s, and in the 1900s. Now remember, these are from dead trees. The longer a tree has been dead, the more likely it is to be knocked over and for it to not be around for us to sample. So you have your evidence is diminishing over time. So we would never expect to catch as big of a pulse 100 years ago as we would 10 years ago. But man, we were expecting some stronger peaks in spruce beetle mortality throughout time, and what we're seeing is a lot of background mortality, and a lot of that could be related to some of the abiotic influences, such as the ruggedness of the San Juan, the instability of the substrate, and the winds. If we look at what live trees are telling us, we see a fair amount of peaks as well. So here, this is the pulse that is being seen by understory trees for this current outbreak. We see a release in the 1960s. Notice we don't see it in the 70s. We did see a pulse in the 70s from the dead trees. My interpretation is that this release is from windrow across the San Juans, which would have started outbreaks in the 60s and which would carry on into the 70s. Outbreaks can go for a decade. We see a nice pulse, spruce beetle activity in multiple areas in the 1900s. That's coincident with some drier weather. The mid-1800s, there's some evidence. But again, we're seeing a lot of releases, a lot of trees in the understory getting pulses, either due to windrow thinning out the canopy or beetle kill thinning out the canopy. And so again, I just want to wrap up that we're looking at past disturbance history as something that might explain this pattern. We're looking at drought. We're looking at the bottom-up influences of stand structure, stand density, and don't have any conclusions to tell you right now. But hopefully this is giving you kind of some insight into what's happening on the ground in the San Juan right now, and some of the things that might be driving those patterns. Folks have any questions?
I'm particularly interested in the west side of the San Juans.
Yeah.
Could you say with any certainty that outbreak on the west side would not get significantly larger, or to the point where we're looking at, say, Williams Creek, some of the more devastated?
I mean, I really couldn't say. We've had an awful lot of dry weather lately, the last couple of years, so I would say, yeah, it's really uncertain to me. The fact that there has been some beetle activity in the west, and now we're having even more drought, it kind of seems to set the stage for more beetle activity in the west. I couldn't say yes or no that it would turn out like what we see in Williams Creek or Indian Creek.
Right. Yeah. What I was kind of expecting was that wave of beetles
Sure.
east to west, and what your research tends to indicate is that those populations on the west side are somewhat separate, or they started not because of all beetles.
Right.
But
my interpretation of these outbreaks, and Barbara, feel free to chime in, my interpretation is that these outbreaks here are independent in terms of population from here. They may have a common driver, but I don't think beetles are flying from here and skipping all of this spruce forest and landing in here. I would say that these are endemic levels of beetles that are going into an outbreak, into a mass attack stage. And I would say the same thing about the southern San Juans as well.
There's been some work for watching the road. This work's been focused on it's natural coming up, and he showed that spatially it's like little pockets that all over the place, including the same thing is shown.
But, and Barbara, how do you feel about my interpretation that this pattern of spread in this direction is probably from populations in this area?
I don't know.
Okay. Yeah, I mean, the monsoon winds tend to drift this way. You do see some spread in this direction as well, but certainly the majority of that spread is following the prevailing wind.
Thick on our side,
Yeah.
kind of western movement is always in the side. Not all in the southwest or down, but the northwest, Chester, and then good movement.
And we were in Benino Creek. No, we were in Hanson Creek here this summer when the flight happened, at least for that area. And those beetles were all moving north and east, at least locally. Yeah.
Or those more westerly spots that you're seeing. It's going to wonder. The last 10 or 15 years, we've seen a lot of increase in spruce budworm and spruce. In fact, 20 years here before anything saw spruce budworm and spruce, and all of a sudden, about 15 years ago, we started showing up in spruce. Now we've got quite a bit of affecting not only the fir, but the spruce too. And armillaria. Seeing a lot of increase in armillaria, probably driven by the fir, but nonetheless, spruce is also susceptible. I've seen spruce dying that I think is probably being affected by armillaria. The infestation that you're seeing in those areas. Any idea if those trees were in fact affected by either one of those? Before they
Yeah, so the question is a relationship between spruce budworm and armillaria and susceptibility to spruce beetle. Honestly, I don't know even what to look for armillaria. It's not something that I was looking for on the landscape. The spruce budworm, it's pretty easy to notice as you're hiking around the forest. You're oftentimes brushing them off of your face while moving through the forest. I saw a lot of spruce budworm, and spruce budworm certainly would weaken trees. You see a decrease in ring width when trees are being attacked by spruce budworm. So it's something that, at least theory would say that, yeah, spruce budworm would weaken a tree to the point where it would become more susceptible. That being, I've been seeing spruce budworm here, there, and almost everywhere. Not as much in the southern San Juans, mostly in the west, here in the east, and a little bit in the northern San Juans, but not as much.
One thing Tom, Peter, and I discussed is in relation to the aerial survey. Because there's so much spruce budworm and armillaria mortality, and if some of it's showing up in the spruce also, if that's really an accurate register on the part of the aerial survey, but it's seeing spruce budworm family instead of.
I don't know. I mean, I was on the ground looking at tree trunks, peeling bark away, pulling, bark beetles falling out of trees. I feel like I did a pretty good job of nailing down that part of my field component. There's a lot of spruce beetle activity out there. I'm not just looking at the canopy. I'm looking at what's going on in the trunk. Now, I couldn't say that spruce budworm didn't, predispose it to beetle outbreak or something like that, but you can be sure that these pie charts are showing spruce beetle activity.